Alright guys, so these are the examples that we're going to go ahead and do on our own. So here's the really cool flip book that I have for you guys, and these are the 6 set of examples that we're going to do pertaining to the individual theorems. Okay, so I think this is really cute how it has the these flaps, and then you can just go ahead and go back and forth to review the theorem and then be able to apply that to these set of problems. So this looks a little bit overwhelming, so I'm going to go ahead and just do 2 problems at a time, and then we'll go ahead and do them together, and I'm going to go ahead and write the answer here. So for this one, it says if AB equals 5x and CD equals 3x plus 6, find AB and CD. So this is the one that says if that 2 minor arcs are congruent if and only if their corresponding chords are congruent. So since we know that their angles are congruent, that the arcs are congruent, then I know that these chords are also congruent. So I'm going to go ahead and set these 2 equal to each other. So I'm going to go ahead and do it here. So we have 5x equals 3x plus 6. Then I'm going to go ahead and subtract 3, 6 from both sides, and I end up with 2x equals 6. And then I divide both sides by 2, and then I get x equals 3. Alright, so that is the very first one. Let's see. So then now I'm going to go ahead, and it says find A, B, and C, D. So in this case, it's asking us to go ahead, we need to plug that in there. So I'm going to go ahead and do that. Let's see, I'm going to go ahead. So we have AB. In this case, so AB is 5x. So and then we found out that x equals 3. So I'm going to go ahead and plug that in, and that equals 15. So AB is 15. Now I need to go ahead and find CD. Well, CD is 3x plus 6. I'm going to go ahead and plug that in. So 3 times 3 plus 6, that equals 9 plus 6, which equals to 15. There you go. Alright, actually, you know what? Let's see. 3, 9 plus, yep. There you go. Okay, now we know that they're congruent, which they should be, because based on the theorem, but their distances should also have been congruent. All right, so now let's go ahead and do the next one. So given that chord BC is 15 from the center of circle A, which has a radius of 25 centimeters, find BC and DE. So so this is a 1 where it tells us that if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. So let's go ahead and break that one down. So it's telling us that the chord BC is 15 centimeters from the center. So from here to here, it's 15. So this little guy is 15, and then it tells us that the radius is 25 centimeters. So I'm going to go ahead, and I know that from here to here it's 25, and this is B, so BA is 25, but also AE is 25, so this is also 25, right? So now, if the whole thing is 25 and I know this is 15, then I know this little part here is going to be 10. So now I need to go ahead and figure out what this part is. Well, this is a right triangle right here because I know that this is a right angle. So I'm going to go ahead and just expand this triangle here. So this is B, A, and D. So I know that this is 25, this is 15, and this is unknown. We don't know yet. So I'm going to use a Pythagorean theorem to figure that out. So I have x squared plus 15 squared equals 25 squared. X squared plus, okay, so when I plug that into my calculator, I get 225, and then this is 625. Okay. X squared, I subtract 225 from both sides, and I get 400. Then I take the square root of both sides, and I get x equals 20. So if this is 20 here, I'm going to go ahead and erase that part. That's BD, right? So if BD is 20, and we know that this bisects the chord, this is 20, this also has to be 20. So it says find BC and DE. Well, BC is now 40, right? Because we doubled it again. 20 times 2 is 40. And then they're asking us for DE. Well, DE, we already just, we found this part right over here. We said DE is 10. I'm going to go ahead and box in my answers. And there you go. Okay, so the main thing for this one, I would say, I think the hard part would be really understanding what the problem is saying and what it's giving us, and then being able to use the information that we know from this theorem to go ahead and apply it. Okay? Alright, so then now we're going to go to our final one, and this one says in circle A, FG equals 3, GA equals 5, and AH equals 4. Find PJ and LA. So this theorem is actually the one that tells us that two chords are congruent if and only if they are equidistant from the center. So these chords A, B, and C, D are congruent if and only if they are congruent, or the distance is the same from the center for both of them. So I'm going to go ahead and plug in what I know. So here's my circle. So FG equals 3. So this little guy is 3. GA equals 5. And AH equals 4. Sorry guys, it's super little. So we have 3, 4, GA is 5. Oops, sorry, this one was a 5. So 5, 4, and then this one's 3. Do know that there's a right triangle here, so we might be able to use a Pythagorean theorem for those. Just already something that's in my mind. So we're using the Pythagorean theorem. If this is 4 and that's 5, then I know from just memorizing the triples that this is going to be a 3, right? They told us that this is a 3. Oh, so if we know that, now we know that the distances are the same from this chord, from the center to this chord, and from the center to this chord, the distances are the same. That way now we can go ahead and apply the information that we have. Now we know that the chords are going to be congruent. So also note that this is a radius from here to here. So if this is 5, this GP also has to be 5. And now we can go ahead and apply the rules. It's also a triple. 3, 4, and 5. Okay, so it says find PJ and LA. Well, let's see. PJ, well, we know that this is actually, if it would be bisecting the chord, right? So now this is 4, this is also going to be 4. And then, so JP is 4 plus 4, which is 8. And then we already decided that these were two. We concluded that JP is congruent to this chord right over here. This one doesn't have a name, but they're congruent because they're equidistant. So LA, oh, you know what? I actually forgot. This is LA right here. This is LA. That's also congruent to LA. Therefore, it's also equal to 8. And there you go. We figured out our answer by being able to relate the information that we've had for actually all of these theorems. This is the really neat part about these circles, that you're going to be able to see how they all connect with each other. Okay, all right, so we're going to stop here and we're going to go ahead and do the next set of examples in another video.